passing complex data structures to your AI prompts shouldn't mean manually converting everything to strings first. You'll see how FastMCP 2 automatically handles serialization for you, whether it's custom data classes, nested dictionaries, or simple strings, so you can focus on the logic, not the formatting. The example will show a single getPrompt call that seamlessly processes a mix of structured data types, all converted behind the scenes.
From Dataclasses, import Dataclass. At Dataclass, class user data. Name, str. Age, int. Async with client. Hash complex arguments are automatically serialized. Result equals await client. Get prompt. Analyze user. User data name equals Alice. Age equals 30. Hash automatically serialized to JSON. Preferences. Theme. Dark. Hash dict serialized to JSON string. Scores. 85, 92, 78. Hash list serialized to JSON string. Simple name. Bob hash strings pass through unchanged.
This demonstrates automatic type-aware serialization for RPC arguments, a pattern that bridges Python's native data structures with external systems. The technique handles complex nested objects, collections, and primitives uniformly, converting them to standardized formats like JSON without manual intervention. What makes this distinctive is its seamless integration with Python's type system, preserving structure while ensuring compatibility with remote endpoints. The pattern works by intercepting argument passing at the client level, where a serialization layer automatically converts typed Python objects into transport-friendly formats. Under the hood, it leverages Python's data classes and type hints to determine serialization rules, while simple types pass through unchanged. This creates a clean separation where developers work with native Python objects, and the framework handles format conversion transparently during transmission. This approach eliminates the boilerplate of manual serialization while maintaining type safety across system boundaries. It's particularly valuable in AI and microservice architectures, where Python backends must exchange structured data with language-agnostic components. The trade-off is a slight runtime overhead for automatic conversion, but the productivity gained from not writing custom serializers for every data type typically outweighs this cost in most applications. Let's break it down line by line.
From Dataclasses, import Dataclass.
Imports Python's data class decorator to eliminate boilerplate in class definitions. It auto-generates init, repr, and other dunder methods, keeping the user data class concise while maintaining type safety. This pattern is essential when you need lightweight data containers with clean serialization.
At Dataclass, class user data.
This defines a data class using Python's @DataClass decorator. It automatically generates boilerplate like init, repr, and equality comparisons, keeping the class definition clean while ensuring proper data encapsulation. The pattern is ideal for simple data containers like this user data model that will be serialized to JSON.
Name, str.
This declares a type-annotated field in the data class, enforcing that name must be a string. The type hint enables static type checking and IDE support, while the data class decorator automatically generates boilerplate like init and repr.
Age, int.
This type annotation enforces that age must be an integer, preventing invalid data types. The data class uses this to validate input and generate proper JSON serialization for the AI tool call.
Async with client.
This establishes an async context manager for the client connection. It guarantees proper resource cleanup when the block exits, preventing connection leaks. The pattern is essential for async operations where manual cleanup would be error-prone.
Hash complex arguments are automatically serialized. Result equals await client, get prompt, analyze user.
This invokes the getPrompt RPC call with automatic argument serialization. The client handles complex Python objects by converting them to JSON, eliminating manual serialization boilerplate. All arguments become structured data for the AI tool without explicit type conversion.
User data name equals Alice, age equals 30. Hash automatically serialized to JSON.
This demonstrates automatic data class serialization. The user data instance with structured fields gets converted to JSON without manual encoding, handling complex Python objects transparently. This eliminates boilerplate serialization code for API calls.
Preferences, theme, dark, hash dict serialized to JSON string.
This demonstrates automatic dictionary serialization to JSON. The Python dict is converted to a JSON string during the RPC call, ensuring complex data structures remain intact across the network boundary. FastMCP handles this serialization transparently, eliminating manual JSON encoding.
Scores, 85, 92, 78. Hash list serialized to JSON string.
The list 85, 92, 78 demonstrates automatic serialization of Python collections to JSON strings. FastMCP handles this conversion transparently, ensuring complex data structures pass cleanly to AI tools without manual string conversion. This matches how the user data, class, and dictionary arguments are processed in the same call.
Simple name, Bob hash strings pass through unchanged.
This demonstrates that primitive strings pass through unchanged without serialization. The RPC system automatically detects and preserves simple types, eliminating unnecessary conversion overhead for basic values. Closing parenthesis completes the dictionary argument. This finalizes the complex parameter structure passed to getPrompt, ensuring all user data, preferences, and scores are properly serialized and sent as a single payload. The pattern demonstrates how FastMCP automatically handles nested Python objects, converting them to JSON-compatible formats for AI tool calls. Automatic argument serialization. FastMCP 2 bridges Python's rich type system with MCP's JSON-based protocol through transparent serialization, letting you pass data classes, dicts, and lists directly while maintaining type safety. The serialization process silently converts complex objects to JSON strings, but remember that deserialization on the server side requires matching type definitions. This pattern eliminates manual JSON conversion while preserving type hints for both client and server.
The argument that becomes a string remains forever a type.